This is a high-resolution topographic map of Mars. We've documented its craters, valleys, and global elevation to the meter. And this is a map of the Moon's far side. We know exactly what the surface looks like, even the side that never faces our planet. Yet back here on Earth, nearly 75% of the global ocean floor remains entirely unmapped. The vast majority of it has never been seen by human eyes. While we track the geography of distant worlds, the majority of our own planet remains a dark, liquid frontier. This map shows the Mariana Trench in the Western Pacific, home to a spot called the Challenger Deep. It sits nearly 7 miles below the ocean's surface. To put that depth into perspective, look at this scale model. If you dropped Mount Everest straight down into this trench, the peak would still be submerged under more than a mile of water. Down there, the environment is purely hostile. Sunlight bleeds out completely by 3,300 feet. The temperature hovers just above freezing, and the water column above exerts 16,000 pounds of pressure per square inch on the seafloor, roughly the equivalent of an elephant standing on your thumb. The Mariana snailfish survives this pressure through specific anatomical adaptations. It functions without a swim bladder and relies on bones made of flexible cartilage to prevent its body from being crushed. Down in the midnight zone, life gets stranger. The black sea devil, or deep-sea anglerfish, navigates the pitch black armed with a cavernous mouth and inward-pointing translucent fangs. This predator survives through a gruesome parasitic bond. When a tiny male finds a female, he bites into her side. Their bloodstreams fuse, and his body eventually dissolves, until he becomes a permanent appendage, a specialized source of sperm fused to the female's body. For centuries, sailors brought back stories of monsters much larger than an anglerfish. They drew pictures of the Kraken, massive, many-armed leviathans dragging entire ships into the deep. Those stories were based on biology. Researchers regularly pull up the carcasses of real giant squids, animals stretching up to 40 feet long. And further down in the water column, the big fin squid drifts with tentacles hanging like puppet strings 26 feet down to the seafloor. Those early sailors weren't hallucinating from scurvy. They were encountering the actual apex predators of the deep. Modern technology brought its own ocean myths. In 1997, hydrophones recorded an incredibly loud, ultra-low frequency rumble in the Pacific. It was so powerful it echoed across 3,000 miles of water. Researchers called it the Bloop. Given the audio profile, early speculation suggested it could be a living creature, an unknown biological leviathan massive enough to dwarf a blue whale. The truth was geological. The Bloop was the sound of a massive Antarctic ice quake, a colossal glacier cracking and calving violently into the sea. That same desire for giant sea monsters fuels the internet's favorite persistent rumor: the idea that the 50-foot prehistoric Megalodon shark is still hiding out there in the deepest trenches. We know exactly how massive these sharks were. This fossilized Megalodon tooth, sitting over a modern great white shark tooth, proves they were immense apex predators. But they went extinct 3.6 million years ago, and they couldn't possibly survive in the abyss. The deep ocean is near freezing and incredibly oxygen-poor. A massive, warm-blooded predator requires huge amounts of blubber-rich prey, like coastal baleen whales, which simply don't exist down there. The forces that rule the deep are deafening geological shifts and highly specialized, slow-moving hunters, not prehistoric holdovers. Instead of giant sharks, the deep ocean hides completely alien ecosystems. This is a hydrothermal vent, a towering mineral chimney situated along a tectonic fault line, spewing a thick plume of black, toxic water. Magma beneath the crust heats this volcanic fluid to 700 degrees Fahrenheit. It blasts directly into the near-freezing ocean water, creating a boiling, pressurized, toxic environment in total darkness. For a long time, we assumed all life on Earth relied on energy from the sun. But organisms down here survive through a process called chemosynthesis. Bacteria living inside the local animals convert those toxic volcanic chemicals directly into usable energy. That process supports massive colonies of life. Blood-red riftia tubeworms, blind shrimp, and ghost crabs form a complete food web entirely cut off from the surface world. Finding these vents proved that life doesn't need sunlight to thrive. It just needs an energy source, even if that source is a boiling volcanic exhaust pipe. Away from the vents, the abyss is pitch black, so biology creates its own stars. The deep ocean functions the largest interactive light show on the planet. We call it bioluminescence, and it is strictly a weapon. Predators use glowing beacons as deadly lures, dangling a bright spot in the dark to attract desperate, hungry fish straight into their waiting jaws. Prey use it too, but as a burglar alarm. When attacked, they'll flash a blinding blue light into the dark water. The goal is to attract a much larger predator to come and eat their attacker. In a world without the sun, emitting light is a massive risk. You might secure your next meal, or you might instantly become someone else's. We still have almost no idea what else is playing that game. With merely 75% of the seafloor unmapped, we are exploring a dark universe where the extreme cold and lack of predators drive some species to grow to massive proportions, a phenomenon known as deep-sea gigantism. We only confirmed the existence of the colossal squid, an animal with eyes the size of dinner plates, in the early 2000s. We have still never observed a fully grown adult alive in its natural habitat. Every time we drop a camera into the black, we document species completely new to science. The real monsters aren't hiding in myth. They are just swimming barely out of our view.